If you've ever lived in a warm climate, you can have an unusual appreciation of something known as cooling. It could be as complex as air conditioning or as simple as a fan, the idea of being able to reduce heat and create better comfort. In a computer, the electrical components create heat because, after all, they're electrical devices. If that heat becomes too high in the system, it can actually cause the system to degrade or shut down. We want to look at methods for heat removal within a system, which is going to include things like airflow and specific cooling systems and so forth. And you'll have a greater appreciation of the importance that cooling plays on these electrical components.
To begin with, let's just talk about the fundamentals of cooling, why you need cooling to begin with, and so forth. Now, first of all, you need to understand how and why heat is generated within a system. You actually see pictured here a circuit board with capacitors, transistors, and all sorts of other things, in this case a computer chip very prominently in the center. Now, electrical components, even those inside a computing device, generate heat due to electrical frequency passing in between them. Here's how this process takes place. First, an electrical pathway exists for power to move across, maybe from a power supply or other component, such as the processor we're actually looking at here with the red arrow. This is the entire path. An electrical signal actually passes along the circuit through the component and onto its intended destination. And as a result, you can see that energy has heated up the pathway, most notably the processor, creating heat which is dissipated into the air. Now, while this seems very simplistic, imagine this happening thousands of times per second, and you could see why heat is generated in an electrical system of a computer. Now, as such, heat can actually create danger to the electrical components within the system. First, it can force a system shutdown. If you've ever driven a car and the radiator has gone dry, you can actually experience this yourself. The engine goes out and you're not able to start it again. Another thing that excessive heat can do is, may not shut down the system, but it can create inefficient operation. There can be errors and other things that happen because the components are running in too warm of an environment. Another consequence of excessive heat could be permanent system damage. It could damage the CPU. It could damage memory chips. It could damage components on the motherboard. Heat is not your friend when it comes to personal computing. And at the very extreme end, though not highly likely, it could be a potential fire hazard. Certainly, electrical causes are not the only fire risks that are involved with computers. In fact, there's something called a fire triangle, and these are all the elements that are necessary and contribute to an actual fire. There's fuel, oxygen, and heat. If you think of a campfire, for example, the wood is the fuel, you obviously have oxygen, and then the heat comes as the wood burns. It's just the fire triangle. And within a computer, fires can be caused not just by electrical problems, but an excess of dust, a great deal of heat, and then obviously the air to go with it, and then you can have a Class A or Class C fire depending on how it ignites. And there are also some other heat factors that you can think about with relation to a personal computer system. First, there's dust. When dust clogs up the various vents of the system, it can actually prevent cooling from taking place, thus creating heat. Poor airflow can be another factor, and this type of airflow issue is not related to dust and clogged vents per se, but for instance, it could be an excessive amount of cables in the wrong location. There could be open vents and open expansion slots and so forth. It can create poor airflow through the system. These systems are designed for the air to be evacuated out in order to be able to keep the system running efficiently. Now that you understand how heat is generated within the computer system, now we can look at how to cool the system down to prevent the types of damage we talked about just a moment ago. So let's look at cooling solutions.
There are some aspects of cooling a computer that you may not even have thought of and may just think are unimportant, understandably so. But we want to take a look at just a few of those principles now, 3 in particular. The first is computer placement. Now, honestly, you don't have any control over the heat that's generated inside the system. It just happens because of the components. But you do have control over where you place the computer. Some spots are more optimal than others. For instance, if you have a desk next to a concrete support pole, you may think that the computer slides in there very neatly and it was almost made for that, but it could restrict airflow and cause overheating. If you actually place the unit toward the back of a cubicle, for example, it could block the air vents and again create problems with the system being able to operate correctly. So placement is not a secondary matter, it's actually of critical importance. The second principle is the configuration of airflow. One of the ways that systems cool themselves off, personal computer systems specifically, is that fans pull air through the system and then exhaust it out the back. It could be one fan, it could be a number of fans. But if you have, for example, expansion slots that are unfilled, or you may have drive bays without covers on them, essentially you're cutting off the airflow and making it less efficient. Covering those types of openings will greatly improve the airflow through the system. And finally, there's routine maintenance. If you own a vehicle, not only does your warranty require that you do certain things at certain intervals, but correct operation of the vehicle is critical that those things are taken care of. Oil changes, air filters, and so forth. And in the same way, you need to do that with your own personal computer. You need to take moments to be able to do dust removal, to be able to clean vents and filters, and other sorts of things to make sure that things aren't being clogged up in terms of airflow or cooling system. Taking these three considerations and making them paramount in the overall maintenance of your system can actually contribute a great deal toward optimal cooling and operation.
One of the first methods for cooling a system, particularly high-functioning components, are heat sinks. These are used to transfer heat away from the source. In this particular case, there are passive heat sinks, which you see the fins. This is designed for air to be able to come through the system and then cool that component. Since there's no fan, it's called a passive heat sink. And then you have an active heat sink, which you'll see very frequently with CPUs. It's where there's a heat sink that's used, but there's also a fan with it to be able to enhance the cooling process. Again, primarily used on CPUs, but sometimes used on graphics cards and other components like that. Now sometimes, in fact almost always, a thermal compound is placed between the CPU and the heat sink. You actually see pictured here in assembly. You have the socket, which contains the CPU. You have the CPU itself, and the thermal compound. This actually promotes the transfer of heat from the processor to the heatsink assembly. Only a thin layer of compound is required. If you use too much, it can actually make the process work less efficiently. So here you actually see the heatsink bracket, the heatsink itself, which we looked at just a moment ago, and then the compounds we also talked about as well. There are different types of fans that are used with CPUs, and essentially they're used to draw heat away from the CPU, again, often in conjunction with a heatsink. You see three different types pictured here. Typically, these fans are powered by a 3 or 4 pin header on the motherboard. It can connect directly to the power supply, or it can connect to a spot on the motherboard, just depending. And oftentimes there's also a mini Molex type or Molex type connector used as well. And this is how these devices are powered. Now, in addition to CPU fans, there are also additional fan assemblies that are used with the system. For instance, you have system fans, sometimes called case fans. These are used to provide airflow through the case. Cool air is pulled in through vents, and then warm air is removed by the case fan. Sometimes you'll see 2 or even 3. In fact, in the system we're assembling as a part of this project, there were actually 3 fans, a forward fan, a rear fan, and a top case fan as well. Essentially, one is used to pull cool air in, the other is used to pull warm air out. And these typically will connect to a multi-pin header on the motherboard. And as we mentioned before, there's also the power supply fan. Now, keep in mind that there are different sizes of fans that can be used. Obviously, there's going to be one size, as you actually see on top of the CPU in the picture. The case fan is larger. There's just different sizes that are available. So keep that in mind. Finally, the sort of grandest, most elaborate type of cooling is liquid cooling. Now, the first thought that may come to mind is, well, wouldn't liquids such as water damage the motherboard? And yes, they would in their native form. But when you're actually used in the tubing system, as you see pictured here with the Zalman Reservator 1 version 2, this actually will cool the system down with great efficiency. You're usually going to use liquid cooled systems with gaming systems because they generate so much heat. Pretty much, the cool liquid runs through a chamber connected to the CPU, the cool liquid absorbs the heat, and then the heated liquid returns to be recooled. There's oftentimes some sort of refrigeration system working with this as well. Now we can actually look at what it takes to install the different types of cooling system on a typical computer system.
So as we discussed, there are a number of different ways to cool down a personal computing system. Since we've taken a look at that, now let's actually apply it to the project that we're working on. First, I wanted to point out a couple of features that are already built into this particular device. First, you see this plastic ring here This is actually for the CPU fan that we'll be installing in a moment. We actually already have the bracket here for simplicity. You also see, however, this sort of gold-colored assembly. You can see the fans for cooling, and then this is actually being able to carry liquid to be able to cool out different parts of the system. So this has already taken a lot of things into account. There's also several fans in the case to be able to assist with evacuating the warm air from the system. Now let's actually take our CPU fan and put it in. You see it also has a number of different assemblies, and then the cooling fins here. Remember, this is referred to as an active heat sink because it has a fan. So now let's go ahead and put it in the system. Take our bracket out. Gently slide it across. Now we actually want to get our assembly aligned so we can put it in. It can be a little tricky sometimes. There's a small hole in the assembly that has to align. Just about there. There we go. Now we get our screw and screwdriver. And we begin to put this all together. Sometimes it requires some pressure to get the screws seated because it is spring-loaded. And there we go. Now it is successfully seated. You can see the fan is now securely fastened. Next, we make our connections. There are a number of different places where there are connections for these. In this particular case, you actually see there's a connector down here. We are able to connect that. And for some of the external fan components, you see we have several here. They also attach in a similar fashion. And that's pretty much the gist of being able to get the external fans connected, the CPU fan connected, and of course these other cooling elements that we already have as part of our system. Thank you so much for listening.
So wrapping up this whole discussion of system cooling, let's go over some critical terms to keep in mind. First, the heat sink. This is a metal device used to draw heat away from electronic components such as the computer's processor. Remember, we talked about active and passive heat sinks. Thermal compound. Remember, this is the substance supplied between the electronic component, such as the processor, and the heat sink in order to aid in heat transfer. Remember, the key is to use a thin layer and not use too much, or can actually make the problem of efficiency that much more complicated. And of course, we talked about two different types of heat sinks. The passive heat sink. This is just a simple metallic assembly that has no additional components and depends on the airflow through the system for cooling. And then there's the active heat sink, which is a heat sink with a fan added designed to facilitate maximum cooling. The overarching principle to remember is that heat buildup in the system, just as heat buildup in your home or your vehicle that you may drive, is not going to be in your or the computer's best interest. So keep things cool.
Inside a personal computer, cooling is more than just simply comfort, as you and I may see it. It's actually vital to the system functioning correctly. It's very similar to the radiator in your car. If the radiator overheats or boils dry, the car will not start and not run. In this way, you need to understand the important dynamics of cooling the system. And by now you should have a pretty good idea of how that works, how to maximize that cooling, and make sure that it continues to operate so that the system will function the way it's supposed to.